right? Around the time of Pangea is when we see the development of these organisms. So this is kind of a fun little series of fossils and changes that occur as you go from these mammal-like reptiles or these therapsids into full-blown mammals. One of the things that I want you to notice in this transition, and again, these are patterns that we see in the fossils through the rocks, is you go from a jaw, a lower jaw that's made up of several elements, and watch what happens to these bones in the back of the jaw through time. They get smaller and smaller until by the time we get into mammals, they're almost just like little leftovers. That jaw becomes a solid piece and attaches more firmly to the cranium. And in so doing, you get these little extra bones in the back. Those bones are repurposed in us, in mammals. The incus and the stapes, the malleus, incus, and stapes are the smallest bones in the human body. In reptiles, there's one bone that makes up the inner ear. In mammals, there are 3 bones that make up the inner ear, which give us the tremendous ability to hear that we have. You know, better to hear you with, right? It's because of those repurposed jawbones. Those repurposed jawbones, we can see the incus and the stapes essentially becoming smaller and smaller and smaller until they're repurposed into the ear. We can see this happening again in our embryos too as they develop, another pattern. And ultimately we get early mammals. Most early mammals looked a lot like these things, little shrew-like organisms. And again, when these things first arose, Pangea existed. And these guys spread all throughout Pangea before it broke apart. And once it broke apart, we start seeing diversification of these little mammals in their isolation. And a great diversity of different mammal groups. You know, today, generally speaking, there are 3 major groups of mammals. The monotremes, like the duck-billed platypus, which retains that reptilian characteristic of laying eggs, right? But it is a mammal. Another thing that's interesting about the duck-billed platypus and monotremes generally is that they lack nipples, like marsupials and placentals do. And the nipple's great so the young can hold on to the mother while the mother is moving around and living a very active life. Monotremes don't have that. You know, one of the defining characteristics of mammals, it's where we get the name, is mammary glands to produce milk for the young. And in duck-billed platypuses and other monotremes, they're just concentrated. Those milk ducts are concentrated in the skin. And what they do is they release kind of like sweat. You know, they sweat their milk out, if you will. And that milk flows down hair on the mother, and the infants can just lick it off the mother, right? They don't have a nipple to hold on to. We see that concentrated in 2 other groups of mammals, the marsupials, those mammals that are born fairly early and mostly reside in a pouch, and placentals that have much fuller development of the fetus within the womb, and then of course later it's born. Placentals have a placenta. That's how we feed the developing fetus, is through that placenta. And that placenta also protects the developing fetus from the mother's immune system. You know, you lay an egg, and no problem, you have an egg, no problem, you protect that fetus. But you got to remember that half of the DNA from that developing fetus is from the father. And the mother's immune system sees it as a foreign body and wants to attack it. So put it in an egg. Placentals chose to protect it using that placenta. Right? So we're called placentals. Anyway, the oldest placentals are from the age of dinosaurs. You know, people often think of the Triassic and the Jurassic and the Cretaceous as the age of dinosaurs, the Mesozoic. But mammals and dinosaurs originated at about the same time on Earth. But mammals stayed small and kind of in the shadows and in their burrows underground, where dinosaurs grew to be very large and dominant. So during the time of the Cretaceous, the time of T-Rex and Triceratops, we have our first placental mammals developing. First evidence for placentas. And boy, mammals undergo a tremendous diversification, but for our story, we're mostly just interested in one group of placentals, and that is the primates. And around 50 million years ago, maybe even closer to 60 million years ago, just right after the age of dinosaurs ended, we start to find the first fossil primates. Now, as I mentioned earlier, and as you probably know, humans are classified as primates. Why? Well, it's because of the patterns that we observe in the bodies of living things. So, if we look at the bodies of living things, primates exhibit a pattern. And let me just go this really quickly. Here's the pattern that primates exhibit. First of all, if you look at a lot of early mammals, or mammals generally, they have a long snout. Primates don't have much of a snout. They have a fairly flat face. They also have forward-facing eyes. Very good vision associated with primates. Relatively large brains for their body mass. Instead of having claws, like most mammals, primates have nails on the ends of their fingers, right? Reptiles have claws, mammal-like reptiles have claws, most mammals have claws, but primates have nails. That's different. That's something that unites us all. We have well-developed thumbs. You know, all primates have well-developed thumbs. They also have generally a more vertical posture. You know, you see them hopping around trees and so forth, right? So, relatively more vertical posture. And also, 2 nipples and relatively few offspring. Small litter sizes. These are characteristics of all primates, and these are characteristics of humans. So certainly if you're going to try to fit this skeleton in this body and this DNA into some classification system, you wouldn't classify us with clams or lobsters or starfish. We don't share the same characteristics, at least as many. So human bodies, we are classified as primates because we have all of these characteristics. Now, something interesting started happening in a population of primates between 6 and 7 million years ago. And those primates started to stand up, becoming more bipedal. Bipedalism is actually very weird. Not many animals have become bipedal. If you look at most mammals, if you look at most reptiles, if you look at most amphibians, most of them are quadrupeds. Humans are an exception. Dinosaurs and birds, their relatives, are an exception.